So our project is all about dynamic monitoring, reporting, and verification for implementing negative emission strategies in managed ecosystems. There are many negative emission strategies, and soil carbon sequestration is one of them. Um, the Currently, there are many policies directed even which will subsidize farmers for adopting certain management practices that will increase the soil carbon, and that's a co-benefit. But looking at the net zero by 2050 for the UK, 2045 for Scotland, the crucial aspect is many of the policies now directed towards for the results. That means they want to pay more policies oriented towards in the direction that they want to pay to the farmer once they achieve that result. But quantification in these systems are really difficult. So the main challenge is to how we quantify the greenhouse gas emissions, how we quantify the verify, quantify, report, and verify the soil carbon sequestration to allow these payments and also reach um, net zero by 2045 in Scotland, 2015 in UK. So this is a challenge. If we look at the currently, there is a lack of cost-effective, robust, consistent, and transparent and accurate methods that limit the large-scale implementation of these technologies. So the main objective for this Retina is to create a iterative, near real-time digital monitoring, verification, and reporting system that will allow us dynamic model forecasting at the farm level. So to do this, actually, we are taking two demonstrated farms, which are also a James Sutton farms, which is one in the Glensock, which is near Aberdeen. Another one is Balrodry farm, which is in Dundee. These two farms, these are the two demonstrator farms where we are demonstrating this technology. We are deploying sensors at three different scales. One is at the farm scale, where we are deploying the sensors, soil moisture, temperature, and all the sensors we are deploying. And these will communicate with the data center. And the next level is the landscape level, where we are deploying a decoherence measurement system. And also we are using the digital RGB photography and aerial hydrospectral imagery. We are trying to combine this to estimate the soil carbon stocks. And we are looking at the soil vertical profile and the aerial, using the aerial hyperspectral imagery to look at the soil carbon variability on the surface, trying to combine this one to estimate the carbon stock. This has never been done before. This is the first time we are trying in this direction. And this is quite evolving technology at this point. And at landscape level, we are using the drones to collect some of the plant parameters. And at the higher scale, at the national scale, we are using the Scintline satellite data information connected with Google Engine to get the real-time information. All will be connected towards this and connect to a peak-in model assembler, which we are developing in high computing facility at the James Hutton, which will be connected in the near real time. The information flows into the system, and this will be projected into two different platforms. One is at the national level grids, which we are producing. We are taking as Scotland, for entire Scotland, we are projecting the greenhouse gas emissions and the carbon change at the national level, and also looking at each farm level. And we are developing an app. The information will be put into the app. Once the farmers use the app will be used to collect the information and also provide the information to the farmers for the decision making. So this will be, the app will be used to collect the information and also pass some of the information for the management change. And we are looking at the scalability of this one from the start of this project. At the farm level, the farmers need basically a bunch of sensors and an app. Then that will allow them, once they deploy these to you, that will allow them to monitor. All the systems will work automatically in that. The idea is to connect the entire flow and project at national scale. That is for the policymakers, because that will give a snapshot of greenhouse gas emission, what's going on from agricultural systems, and also the carbon sequestration potential in these things. And more farmers will join into each grid that will become more and more robust at the national level estimations. This is the scalability which we are looking. The overall output for this one is to development of a dynamic cyber infrastructure that connect the multi-scale sensors using the artificial intelligence to novel cloud-based modeling approaches, allow us to detect the changes in soil carbon change and GHG emissions. This is a more or less we are doing this so far. It never been done in that scale so far. This is the first time we are attempting this level.